Alright, this one's similar to question 9, part A and B. So if you did that one and did well with it, the only difference with number 11, part A, is you can see that the numbers are just a little messier, but it should take the same approach. Okay, so to use Sohcahtoa, we need a right triangle. Sohcahtoa is right triangle trig. And I don't see a right triangle here, but you can take this point on the angle, or on the terminal side of the angle, and draw it to the x-axis. That creates a right angle and a right triangle. And to get to this point, I can know I'm going left square root of 3 and down 1. So not only do I end up with a right triangle, I end up with two sides of the right triangle. Okay, so all of this in red is the theta, and then this little angle inside the reference triangle is the reference angle. So I'm going to call that theta prime, so I can tell the difference between those. So both of these have the same sine, cosine, tangent, so now I can just kind of look at this one from here on out. Okay, so for the reference angle, if I know opposite and adjacent, that means the only one that's ready to go would be tangent. Here's opposite over adjacent. Not only should you reduce negative over negative, but you should also rationalize. Okay, for cotangent, you could take the reciprocal of this, and you could put 3 over the square root of 3, but then you'd have to rationalize that. A smarter thing to do would be, because it just saves you a little bit of space, to say, wait, tangent was also 1 over the square root of 3, so if I took the reciprocal of that, it's just the square root of 3. And that saves you a bit of work. But those are the only two I can do without finding this hypotenuse length. And to find the hypotenuse length is not going to be a big deal because of Pythagorean theorem. Leg squared plus leg squared equals hypotenuse squared. This ends up being 3, 1 is c squared. So c is the square root of 4, but just the positive version, so 2. All right, now that I know that the hypotenuse is 2, sine is opposite over hypotenuse. Now these values are starting to look familiar to me, so I actually know what angle that is from the unit circle. So I can either finish it that way, or I can just go ahead and pair up the rest of these ratios, which is what I'm going to do. Reciprocal of sine gives you cosecant. Cosine is adjacent over hypotenuse. And then secant would be the reciprocal of that. This one would need to be rationalized. Multiply the top and the bottom by the square root of 3. So that way it's like you're multiplying by 1. And square root of 3 times square root of 3 is 9, or square root of 9, but that just reduces to 3.